Dear friends, we are uh, going to understand the concept of average speed and average velocity with the help of two simple problems. The first problem is really very simple. It is about a car which is moving along a straight road. Okay, all our problems are based on the straight line motion in this case. So when the car is moving, it is initially moving fast, that is what is given, at 80 kilometer per hour, and then it slows down and it moves at 40 kilometers per hour. Okay, so this is, it moves slowly, and we are required to find the average speed. So the average speed formula, is the total distance upon total time. Total distance upon total time. Okay, so what is the distance which is covered? So initially, this distance, let us say that the total time is t. Total time is t. Okay, now what is given is half of its time. Half of its time is t by 2. Half of its time, the car is moving at 80 kilometers per hour. So you know that distance is then speed into time. Speed into time. So it is moving, the half of the time, the distance covered would be 80 kilometers into t by 2. So it is 40 t. The remaining half of the time, it is moving at 40 kilometers per hour. So it is moving slowly. So how much distance it will cover? It would cover the distance which is less. Speed is how much now? Speed is 40 kilometers per hour into the time is t by 2. Why t by 2? Because half of the time, remaining half of the time. So t by 2. So this becomes 20 t. So what is the total distance covered? It is 40 t initially plus 20 t afterwards. So it is 60 t. So 60 t upon t. So it becomes 60 kilometers per hour. So the answer is average speed of the car is 60 kilometers per hour. Okay, so how do we find average speed? By dividing the total distance upon total time, you calculate the average speed. Okay, now let us go to the second example. So let me rub this and go to the second case. It is about a boy which is walking from his home to the market. Okay, and it is given that the market is 2.5 kilometers from his home. So okay, you also must have gone to the market, right, from your home. And I am assuming that you also, if your market is near, you don't use your bike, but you instead go by walking. It's a good exercise. So let us say that this boy is a good boy, walking at a speed of 5 kilometers per hour, okay, to the market which is 2.5 kilometers away, right? So how much time does he walk? First we'll find how much time does he walk from his home to market. So for finding the time, okay, time would be what? It is a straight line. Okay, the time would be, because speed is distance upon time, so time is distance upon speed. So distance is 2.5 kilometers and the speed is 5 kilometers per hour. Okay, so the time required for the boy to walk from home to market is 2.5 upon 5, which is nothing but half an hour. So half hour for walking straight, okay, not by like this, for walking straight from home to market, he takes about half an hour or 30 minutes. 30 minutes, okay. Now what he does is that he comes from market back to the home because he finds that the market is closed. Okay, so market is closed. So let us say that now he has to travel back. He has to travel back from the market to his home. So first what he had done, he had gone from home to the market straight. Okay, he takes 30 minutes, which I had calculated. Okay, because he is traveling at a slow speed. Okay, and he covers 2.5 kilometers. But because the market is closed, he immediately comes back. He does not wait. So the time he is waiting in the market is 0. But he comes from the market to the home and he is left with 20 minutes now. Because the total time is 15 minutes. So 20 minutes is left. Now let us see how much distance he is traveling, whether he is reaching to the home or he remains midway. Okay, so for that we will calculate the distance. Okay, so you know that speed is distance upon time. So distance is speed into time. So speed now he has increased, he is walking fast and he is left with 20 minutes, which is nothing but 20 upon 60 hours. Okay, so the speed now he has increased to 7.5 kilometers and his time is 20 by 16. Okay, hours. So this becomes 7.5 upon 3, which is 2.5. Okay, which is equal to this distance from the home and market. Okay, so it means that he has again traveled 2.5 kilometers back and he has reached home. He has reached home. Okay, so when he has reached home, it means that his displacement is 0. He has started from home, he gone to market, come back again to the home. So he has reached home. So the displacement is 0. Okay, his displacement is 0. Why is it 0? Because he has gone 2.5 kilometers and then he has come back again 2.5 kilometers. So the net distance traveled is 0. So the velocity, which is displacement upon time is 0. Okay, but the speed is not 0 because he has traveled some distance. So how much is the distance he has traveled? So he has traveled 2.5 kilometers plus 2.5 kilometers, that is he has traveled 5 kilometers. And how much time did he travel? So for going he took 30 minutes and for coming back he took 20 minutes. So all in all he took 50 minutes, which is nothing but 50 by 60 hours, or he took 5 by 6 hours for total time of travel. So the average speed is total distance upon total time. Total distance is 5 kilometers, total time is 5.6 hours. So this gives you 6 kilometers per hour is his average speed. So average speed is 6 kilometers per hour and average velocity is 0. I hope you understood this concept very well. Okay, so average speed you calculate it as a total distance upon total time, and average velocity you calculate as displacement, total displacement upon time. And the answers for this problem is average velocity is 0 kilometers per hour and average speed is 6 kilometers per hour.